now we're going to look at types of triangles. So if a triangle, hopefully it's not tricky, a triangle has three sides. If they are three equal angles, so if these angles here are all equal and these lengths are all equal, it is known as an equilateral triangle. With two equal lengths and two equal angles, it is known as an isosceles triangle. Now, these two angles here, so the equal ones, are known as the base angles. A right angle triangle, the clue is in the title. It has a right angle. Okay, so it has 190-degree angle. And the last one has no equal length and no equal angle, so everything about it is different. That is known as a scalene triangle. A right-angled isosceles triangle is a combination of the right angle and isosceles. So, that means that this angle up here would have to be 90. But because it's an isosceles triangle, and we also know something else about triangles, in that angles in a triangle, the three angles in a triangle add to 180, that if this one is 90, and we know that these two are equal to each other, then these two must both be 45 degrees. So for a right angle isosceles triangle, they would always have these angles. So it would have one 90-degree angle and two angles of 45. Let me just go back up to the equilateral triangle. If we know that they are three equal angles, again, we know that the angles in a triangle add up to 180. So if they're all equal, then each one would be 180 divided by 3, which is 60 degrees. So, review of triangles. All triangles, in any triangle, no matter what type it is, their three angles add up to 180. We've just discussed that. So the examples are here. If we're trying to find the missing angles, because these markings indicate it's an equilateral triangle, A and B and C are all equal to each other, and they are all 60 degrees. For this missing angle here, D, what would we do? What we would do is add up these two angles, so we'd find out what 80 plus 60 was. Okay, and we would then subtract that from 180 to give us angle D. Okay. Next one is an isosceles triangle because of these two markings. So this is 40, indicates that this is the other base angle, so E is 40 degrees. This one at the top, well, if these are both 40, then 40 plus 40 is 80, and 180 subtract 80 gives 100. So angle F is 100 degrees. Another isosceles triangle. We know these two are equal to each other. We know that they all add up to 180. So similar to the isosceles right angle triangle we just had, these two angles here would give us what's left from the 180 once we've got rid of the 30. So we work out 180 subtract 30. And we then divide that answer by 2 because we know they're equal to each other. So G and H are both 75 degrees. Looks like initially we don't know all the angles here we need, but this marking here, we know it's a right angle. So 90 plus 45 gives us 135. 180 take 135. gives us 45 degrees for angle I. Okay, and the final page here is looking at quadrilaterals. So a quadrilateral is a shape with 4 sides. Okay, this shape that we're talking about here is a rectangle. We know that each of the 4 angles in this 4-sided shape are 90 degrees, which means that if we have 4 lots of 90, gives us 360 degrees. So the total makes 360 degrees. But is this true for any quadrilateral? So what we've done here is we've drawn an irregular quadrilateral. So, sorry, I shouldn't use that mark. So each of the sides are different. If I were to draw in a diagonal going down here, I know that these angles here are in a triangle, therefore that those red ones add up to 180. I know that these angles here are also in a triangle, so I know that they would also add up to 180, and 180 plus 180 would give us 360. So the angles in any quadrilateral, 1, 2, 3, 4, these 4 angles would always add up to 360 degrees. So we have this quadrilateral here. If we're trying to find B, we would add the 3 that we've been given. So 5 and 5 is 10. 9 plus 1 is 10. 13, 19. And 1 and 1 is 2. So that's 290. If they add up to 360, we get 70 degrees. So B would be 70